Welcome to our YouTube channel. In this video, you are going to understand the meaning of FEA in simple understandable examples. So let's start. Finite element analysis is the use of calculations, models and simulations to predict and understand how an object might behave under various physical conditions. FEA simulations are done by computers to boost the numerical calculation speed. Before directly moving to understand FEA, let's have a look at simple tension test. A tensile tester, also known as a pole tester or universal testing machine, is an electromechanical test system that applies a tensile force to a material to determine the tensile strength and deformation behavior until it breaks. In this simple tension test, a rod is pulled until it breaks. So we can predict the failure of this rod using an experiment with the help of UTM. But these experiments have a huge cost, and we can only test simple rods or simple structures using physical testing methods. From the strength of material books, we have learnt about formulas to calculate the stresses and predict the failure. So, from available formulas, stress in this rod can be calculated easily as stress is equal to tensile force divided by cross-sectional area. Available formulas can be used only for simple geometries like rods, plates, beams, etc. Now take an example of aircraft engine. Can we be able to calculate the stresses and predict the failure of blades using available formulas? Simple answer is no. Calculations of such complex geometries can be made using numerical methods. Numerical methods use matrix formulations to do the calculations. And these calculations are very time-consuming because matrix size depends on the number of variables. So here comes the role of finite element analysis, which uses computers to speed up the numerical method calculations. Now you have got idea of how FEA is useful to do strength calculations on complex geometries. Now let's understand FEA in more details. Now let's have a look at different steps in FEA. Any FEA model starts with CAD geometry. Created geometry can be 1D, 2D or 3D depending upon the problem. After creating geometry, geometry needs to be divided into number of elements. This is done in meshing step. Created mesh can be 1D, 2D or 3D depending upon the CAD. After we have meshed model, loads and constraints needs to be applied in next step. After applying boundary conditions, applying material is very important step. Materials of structure needs to be checked and applied in this step. The final step is results. In this step we get the calculations of stress, deformations and many other parameters. Now let's understand each step in details. First step of FE modeling is to create the CAD. The creation of CAD depends on the type of geometry. If geometry is having cross-sections along length and length of geometry is large, then we can create line bodies only and assign different cross-sections to it. Examples are beam, rod, shafts. If geometry is having sheets, plates with small thickness, then we can create surface bodies and assign the thicknesses to it. Examples are BIW parts, sheet panels. If we have thick geometry or parts which can't be created as 1D line bodies or 2D surface bodies, then we can create 3D bodies. Examples are engine blocks, pressure cooker. As an example for FEA steps, we will explain the example of pressure cooker for further steps. As the selected example is pressure cooker, it cannot be meshed with 1D or 2D elements. Some people may doubt this, as pressure cooker can be meshed with 2D elements. Yes, they are right. But as pressure cooker needs to be designed against the cyclic pressure loading, 3D mesh approach is accurate to capture the stresses across wall thickness of pressure cooker. Hence the pressure cooker is meshed with 3D elements. Now let's understand the boundary conditions step. Pressure cooker is subjected to pressure and thermal loading. It is critical to find the right wall thickness of pressure cooker and find the right design pressure for safety. Pressure generated due to steam will act on inside faces of pressure cooker. Similarly, the steam temperature will act on inside faces of pressure cooker. From outside it will have ambient conditions. Suppose people uses pressure cooker for 5 times a day. So pressure and temperature will vary from design conditions or maximum conditions to ambient or minimum conditions. If pressure manufacturing company provides 10 years warranty on pressure cooker, then the pressure cooker needs to sustain the cyclic pressure and thermal loading for 18,250 cycles. This will be the fatigue life of pressure cooker. Pressure cooker will rest on gas or stove. So the resting surface will be constrained in vertical direction. Now, identifying and applying correct materials to each parts of pressure cooker is important step. Pressure cooker walls are made up of metals like aluminium or stainless steel. Safety valve and sealing ring is generally made up of rubber. Pin valve is made up of metal like steel and handle is made up of plastic. For analyzing the linear static structural analysis and thermal structural analysis, we will be needing properties of all material like Young's modulus, Poisson's ratio for static structural analysis, thermal conductivity for thermal analysis, and coefficient of thermal expansion for thermal structural analysis. After completing CAD modeling, meshing, boundary conditions and material steps, we can solve the analysis to get the results. From analysis we will have results like deformation and stress results of pressure cooker. Stress values of pressure cooker are compared with allowable limit to decide the failure. So here ends our today's video on Introduction to FEA. Thank you for watching the video. Please like, share and comment on video. Don't forget to subscribe the channel. We need your support to make more quality videos like this.